So first of all, good morning to everyone. As you people have joined at different moments, I started talking a few minutes earlier. Again, before we start the course, I want to say that please don't hesitate to reach out, send email. Don't let anything hold you back. I'm here to make sure that all of you are successful. So please don't hesitate. And there are no bad questions, so you don't have to filter your questions. Okay. Now, so today's class is going to be interesting and special in the sense that I'm going to give you, it's a very ambitious class today. I'm going to try to give you almost all of the core of Python programming that you need. So after this class, you should be able to start writing programs. And so there will be plenty of time for you to reflect and absorb everything that we have discussed today. If there's anything you want to discuss more, we will have office hours on Monday, so we can follow up and make sure you get more time. So don't feel like I'm rushing through, but there is something pretty, as I work through setting up this stuff, there's something pretty at seeing this whole panorama of ideas laid out in one shot. And then you can pick and choose and drill into things as needed. Okay. So what did we, just quick recap from last time. All of you should go to the web page and make sure you're logged in, because today we will try to do write some code and solve some problems and so on. In fact, I will ask for volunteers in a minute. Okay, so just quick recap from last time, right? I showed you that Python, we talked about why Python, and we talked about some simple ideas in Python that you can use it as a calculator. I gave you this big idea that asking questions is really important. No matter which field you're in, just generating a lot of questions is a wonderful way to learn. And then the next step in this course is trying to figure out, once you ask a question, how do you solve it? Okay, so as we go through this course, please practice this, right? With your friends, with your family, try to generate interesting questions, and there's a lot of reward there. And then we talked about variables, expressions, and types. Okay, and I have a little vignette here. So let's just see, just to show you that even though we can introduce an idea, there's always some tricky detail that remains. And technically, that tricky detail should be unlocked when you're working by yourself. This is where practice comes in. But just to highlight it, let's look at this code. And there's a poll here. It's only 2 lines of code. So there's a variable here called bonus. It's set to some number 6,000. There's a variable called salary. And we compute the total salary. And let's say the company realized that the bonus was wrong, so they updated the bonus. So what is the total salary right now? Can you all take the poll quickly? Let's see what happens. Okay, so I'm gonna give it one more second. Yeah. Okay, so you see there was a trick in there, right? And so some of you at least thought it might be 70,000. Okay, and I'm going to show you quickly. So this is where it's tricky, right? I mean, programming is very tricky. So I'm going to make a comment. These are the kind of comments that I think intermediate programmers will appreciate. For you, if it's a little bit abstract at this moment, it's all right. But this idea that whenever we keep state in variables, by state, I mean we remember information, then when we make changes to our program, we must remember where all we have stored bits of state. And we must ask the question, who needs to be updated, right? And in this type of code, so here's a little visualization. I want to show you some ideas here. So if you look at this code here, you see that this visualization shows us what is happening inside Python, right? When we create a Python program, this is the internally. And so if I step through this program here, you see internally in Python, what's called a global frame. Think of it as a storage module, right? In this global frame, a variable bonus has been created, and it's set to the value 6,000, right? Now, if I step through this, another variable called salary has been created, and it's linked to the value 60,000. And now total salary has been computed, and it is 66,000, right? Now we're going to update the bonus variable. So you see the bonus variable has changed, but the total salary is not being updated. It has already been computed and linked to the value 66,000. So if you go back and change the bonus variable, it's not going to affect total salary. And now if I print it out, it is 66,000, right? So variables are updated as soon as that line is evaluated. If you really wanted to update the salary, you must recompute total salary again. So basically, you must reassign this variable again. Okay, so tricky example, but this is what practice helps us, right? When you write this, it'll become a bug in your code, you'll have a problem, and then you'll build up this mental model. Variables get frozen as the code is running through. Always think of code as a top-down execution. We'll talk about branches later, but it's a process that flows instruction by instruction. So if you make updates, we have to always bear in mind who needs to be updated. So maybe a short way of fixing this problem is to say, don't keep state all over the place. Okay, and we'll come back to this as you keep writing code. Okay, so now for this session, right? So this session, I want to talk about functions. I don't want to spend too much time going through this, but just to tell you, I want to talk about functions, then talk about how can we control the behavior in our code. That's a big idea, right? All of the logic in our code, which takes us to the field of logic. We'll talk about some elements of logic. I cannot give a full course on logic here, but some of the programming constructs there. Then we'll talk about loops. And in the survey, some of you had said you want to get comfortable with loops. So we'll write some simple programs here and slowly build up that repertoire. I have left some learning tips here. I don't think I need to read it out for you, but they are important, right? So it's one thing for me to tell you an idea, but it's another thing for you to make it part of your own mental model. Right? Transferring my ideas so that you can make it part of the way you think takes a little time. So give yourself the chance to do that. Sometimes when a lot of information comes, it can be overwhelming. So that's also all right. It's part of learning. Okay. And then if I can help in any way, don't hesitate either now to ask questions or later. Okay. So let's get started. We're going to talk about functions. So I want to use a metaphor here. I want to say that functions, think of functions. Lego blocks are kind of interesting metaphor in the sense, but the one thing that Lego blocks don't fully capture is the notion of an interface. That means an interface is a place through which information flows into the function. Okay, so here I'm going to show you how to describe a function abstractly. So we have already looked at the print function and the input function. Let's spend a minute trying to re-understand the input function one more time, right? So every function has a name. So in this case, the function is called input. It has a parameter called message. I've called it message. It takes a string message. And the fact that it's a string, it has a type string. It has a type of string, right? So whatever this function takes for now, one parameter, okay? And it prints something to the screen. That's a tricky function. It goes and does something in the side, but then it gets an input from the user and it brings a string back to you. So immediately when you look at this function, you should be able to think of it's something that takes a string and returns a string. Some languages, in fact, Python is moving to allow us to make declarative statements about functions like this. Okay, it's a bigger debate whether this information is part of your thinking model or not. Okay, for those who come from C and Java, this is called the function signature. And the function signature is part of your thinking model, right? Because it tells you what a function can take and what it can return. So you kind of know how to use it. You will see me use the language of calling this the function interface or the function signature in different places, okay? So that's a quick thing for us when we encounter new functions, immediately recognize the signature of the function. And when we're writing code, we load up in our memory, in our current memory, what is the signature of the function. That quickly tells us how to use it. Okay, so much for theory. Can you all just quickly delete this code and or read it or run it? And just as you're doing this, bear in mind what I just said. Input takes a string. It's going to ask the user for some value. It doesn't matter whether you ask the user to enter a name or you ask the user to enter a number. It's always going to come out as a string, right? And we had talked about checking this. You can always do print, and you can use the type keyword here, and you can check what is the type of this variable, right? So if you want to verify at any moment in time a variable like name, if you want to verify what is the nature of this variable, you can always ask what is its type. Okay, in the beginning, it's kind of something that I used to use a lot, not only in Python, every new language. I'm curious to see what the type is. Okay, and it's nice to ask the language. A lot of intro programming courses will make you do this in your head, figure out the type of something, okay, which is also a nice skill to have. Okay, quick poll then. So I think we just talked about input as a specific example, but are you comfortable understanding signatures of functions? If I show you a function, you can figure out a signature and figure out how to use it. Quick yes, no, need more practice, so I can see where you are in your thinking. So I'm going to say yes for myself. Give it one more second. Okay, I'm going to make you guys click a few buttons today and type a little code, okay? Hopefully that's good. Okay, so many of you are comfortable with this idea. Of course, some of you with programming backgrounds and so on, that's okay. Just a little practice and this will become completely natural. So I'm going to go to the next section here. So, okay, so now we know how to use functions. The next step for us is, okay, if there is, okay, so now I'm going to make a statement here. I want you to start thinking of our whole program as built out of small functions that we connect together, right? One function does something, it passes some values to the next one and then to the next one and the next one. So thinking about solving a problem as a collection of functions is an advanced skill, right? As soon as I see a problem, I can start to see what functions I will need. I want all of you to start developing that skill. But anyway, before we can go there, we must know how to write a function. So today we'll spend a few minutes on this, okay? So again, when you're creating a function, you must also have some idea about the signature of the function. So here's a simple function called double, okay? And here I'm going to give you the template. This template you should learn and keep in your mind. Python functions always start with the word def. That's a keyword. It's telling Python I'm going to define a function. Then you have, is the font big enough or is it too small? I can make it a little bigger if necessary. Why not? Is this better? Somebody can tell me, yeah, okay, yeah. Okay, so you can take this function and give it, sorry, you do the def, then you give it a name, right, whatever. Now, naming functions, very important. If the function name is, I stress this a lot because the counterpoint to not naming a function well, by well I mean self-explanatory, what does this function do, is then you have to write a comment and explain, or you have to write what is called a docstring. So for the first part of this course, at least, I'm not going to emphasize comments and docstrings. I'm going to try to urge all of you to figure out what is the amount of information I need to create so that the function will describe itself from its names. And in the beginning, there might be long names. Okay, don't force that the function name needs to be short. There's a shortcut where everything is called T and N and F and so on and so forth. But let's give them good names. So there's a name. Then there are two parentheses, right? And then you can pass the parameters of the function you can declare the parameters of the function in this parenthesis. So if you had more than one, you could have different parameters here. Okay, but for now, let's just focus on one parameter functions. Then the important part in Python, which is you need a colon, right? And this, for those who have worked in C and Java and so on, those languages will use curly braces like this to denote the body of the function. Okay, and when Python was created, there was this desire to try to make it easier on the eyes, quote unquote. Those who have learned to use curly braces will say it's very easy on my eyes. It doesn't bother me, right? But anyway, so we are here. So Python does it in a clever way. It still needs to know what the body of the function is. Python does it in a very clever way. It uses a colon. And then all the body of the function must be indented. So if you go here, you hit one tab. Okay, later we can talk about indenting styles. But one tab is an indent. The indents must be consistent. That means if I have, so if I have multiple lines, all of them must be indented to the same amount. And the moment I start a non-indented line, that means Python knows the function is over. right? So I could put multiple, let me not write code for a minute. If I say line 1, and then if I say line 2, so I can type a lot of lines of code here, but all these lines have to be consistently indented. If there's any misalignment here, Python will complain because it cannot figure out when the function is over. Okay, so it's a very important idea here to do this. So let me just repeat one more time for those who haven't used created functions in Python before. You start with the def. Actually, I did put it down here. So let's just look at this. You start with the def. You have the name of the function. Then you have all the parameters that you need for that particular function. Forgetting colon is a typical bug for starters, beginners, because you don't remember this. Then you have the body of the function. Notice that they're all indented to the same amount. And then there is an optional return. So return allows the function to return a value. All functions do not have to return a value. You could just have a function that prints something and does not return anything. Okay, later we can talk about style guidelines. When shall I return something? When shall I not return something? But right now you have option to return a value. For today, at least most of today, I'm going to allow you talk only about functions that return a single value. You can put it in the back of your head, even in your notes, and you can ask me later. If I need to return multiple values, what do I do? Okay. So that's it. So please keep this template in mind. Spend a minute or two after this class just reviewing this template. Of course, the best thing to do is to write a lot of code. So can everybody quickly just write? Actually, can I ask, if it's not too much trouble, can I ask for a volunteer to type some code? Yeah, okay. Way to go. So let me stop sharing my screen and you can share your screen. Okay, beautiful. Perfect, perfect. Yeah. So we will use you to type. If you know the solutions, you can type. Okay, so the first goal was to create this function called double. I think you've done it right. So now the next one was to create this function called triple. So all of you can follow along if you want, or you can do it later. That's also fine, right? So, okay, yeah. So these are simple functions, right? So they all return one value. Perfect, well done. Okay, and now you can print it out. Excellent. Okay. Okay. So this is cool. I just want to say one small detail for those who are watching carefully is that triple is actually returning an integer, right? If you print out the type of the return value or store it in a variable and check, you can make it a float if you want, then it'll put a 0.0. But actually the thing I wanted to highlight to you is print wants strings. And we have not explicitly converted this to a string. And in this case, print helpfully converts it to a string. But if you want to join this value with another string, for example, can you just add a string in the beginning of this line, inside print in the beginning of print, after the bracket, inside print, before float. Yeah, if you say the answer, put a single quote, no quotes, like what's a quote? To make a string, you need quotes, right? Yeah, exactly. You say this is the answer or answer. It doesn't matter what you type. No, just stop typing. Start typing after the quote. Yeah, answer. And then close the quote. Now put a plus. Right? So we think that we are joining two strings together, but this will break. Can you try? Yeah, because it now print says I cannot help you anymore. I will not automatically convert it for you. So now you have to put an str around the float, or remove the float and make that str. Yeah, exactly. Yeah, either way. Okay, so I want you to just know these ideas. Even in a small program like this, knowing what is the type, what I can pass to print, etc. is important. Okay, so I think we beat that concept to death. So now let's just make sure I don't have anything else on that page. Yeah, actually, okay, so let's just scroll down to the bottom. There's an interesting visualization. If you just scroll down a bit more. So this is a very important idea here, that I'm going to show you something. Again, it's a mental model, right? So I want you to play with this after the class. If you hit the forward button, you see we have declared a variable n. And in the global frame of your program, there's one variable called n. Now we have a simple function here. And the job of this function is add a constant to n. And if you see what happened now, Python seems to have skipped over that function, but actually it has created in its mind or in the global frame, you see this thing called add constant. That's the name of the function, and it's pointing to the function itself. So Python says, okay, you've told me what the function is. So when I talk about programs later, I will use the word declaring a function. This is when we have declared the function to Python. So Python knows what the function is, but Python hasn't actually evaluated the function. So even if there are bugs, at this moment, Python will not complain. Okay, on certain types of bugs it might, but in general, you cannot. It does not really explode the function at all. So now if you run the next line, so now you see that there is this variable n, we have printed it out. Now if we go to the next line, it's going to evaluate this function. See the difference between declaring and evaluating. So now Python says, okay, you want me to evaluate this function, and you see the red arrow has moved back to that function. And now if you hit the forward button, it goes line by line inside the function. The first thing to notice is that it has actually created a local frame now. Right? And in this local frame, it stores everything that this function needs to work on. And you can see I particularly made this bad piece of code or this tricky piece of code to show you there are two variables, n. And inside the function, this variable has been changed, and now its value is 5. But outside the function, there is an n whose value is 3. And Python will always use the value that's inside the function frame, not in the global frame. Right? So this is very important. So the local value n hides the global value of n. So it actually knows now that n is 5, and it's going to return 5. So if you hit forward, 5 comes back, and you see it on the screen. Yeah, it gets printed out. So I want all of you to understand this idea that when we create a function, and when, first of all, you define the function, and then you evaluate the function. Very often it's a beginner's bug where you define a function and you say nothing happens. That's because you haven't actually invoked the function. For example, in this program, that function is not invoked until you reach line 11. Okay, again, it's fairly simple ideas, but these little ideas stack up, and then eventually when you have a big program, it's hard to figure out why something went wrong. So, okay, so I think we can go to the next page now. Okay, so this is a bit wordy. I will just call your attention to it. Please take a minute to read through this carefully. There's some more advanced thinking behind these ideas, okay? Maybe I will just talk about the blue highlights here. You can read it in carefully. So the first idea is components. Think of functions like Lego blocks or things to build your program out of, and then we assemble them together, right? So I want to change, and this is, not everybody teaches this way, but I really want all of you to think in terms of components. That's an advanced style of thinking. It's very easy to think in terms of lines of code and detailed logic, but here I'm teaching you functions up front so that I want you always to think in terms of components and gluing components together, right? So if you can do that, that will give you a step up in your learning of Python. The next thing is, as soon as you're thinking in terms of components, you must ask what is the interface of the component, what goes in and what comes out. Then you can glue them together, okay? And now there's a very interesting idea here that when you're working at a high level, you only ask the question, what are the components and what is the interaction between the components? Each component, each function can be complicated inside. So you work in two ways. At one level, you're gluing things together. At another level, you're inside the function and you're writing it. Okay, so this high level, low level switching of thinking is very useful. And then the last piece, we will cover this in detail, how to test and debug these functions as little components. So you take a big piece of work and you break it down into smaller chunks. And if you understand each small chunk, you're well on your way to assembling a solution. Okay, again, a structured way of thinking. We'll do an example soon. So can we go to the next tab? Okay, quick chance for you to write it. I think it's already there. So, but you can delete it. Let's delete and quickly write the main function, I guess. Yeah, so this is a good example, right? Just deleting something and just typing so that your fingers get used to typing quickly. That's a wonderful, yeah. You start writing def, mean, yeah.
Just wondering if everyone can see the font or you need.
He made it bigger, so I think it should be
I
okay.
think so.
If,
I
if
think
anyone,
this is half of the screen is showing as a screensaver. Yes, anyway, it can be expanded to full screen.
yeah, yeah, you can. Just pull it to the right. That's it. Yeah, it was a very nice, relaxing screensaver. I was enjoying it. Okay. Okay. Yeah, the colon comes back. And now, that's good. There's something missing. Yeah, you have to explicitly say print. Okay, that's it. Okay, so that's this is a wonderful way for you to see how we build up the skill, right? It becomes muscle memory. So when I type a function def, the semicolons, the indents, it's all, I'm not thinking about it. So I can focus my mind on the content of what I'm going to write. I don't make those mistakes. Python is unforgiving, right? Programming languages are unforgiving. If you make a colon mistake, it's going to complain. Okay, we can go to the next one. Next, yeah. Okay, so this one is going to be interesting. So I'm going to give all of you a couple of minutes before we start typing, okay? You have all seen this idea of, how did we call it? This idea of how, I gave you this problem walking across the country. And if you think about the code that we used, there was a lot of code there, right? So the challenge for us is to say, can we use functions and break that problem down into small pieces of code? Okay, and I'm going to help you design this, right? But just to give you a head start, can I give you a minute just to clear your mind and say, okay, what kind of functions would I need? This is a challenging idea. You can take the code from before and reshape it, or you can think of this problem from the beginning, but top down, okay? So to start off with, I would say if you start very top down, maybe we can start at this level, which says a function that I could use is a function that computes the number of steps given the width of the country, right? So can we create such a function? So let's go ahead and do this. Def. So we have to give it a name. So let's just give it a name. Yeah, walking time. Let's use the convention of walking underscore. Sorry, I'm being pedantic. Underscore time. Yeah. Oh, okay. Colon. Put a colon quickly. Let's just write a. No, you know what? If you want to do the parent, that's fine. So what do we need? What information do we need? So I'm going through this painstakingly because I want you to think about it. But I've given you a clue on the right-hand side. So walking time needs what? We need to know the width of the country. So you can have a parameter called width, I guess. We need to know how big your step is, maybe because you're going to calculate, step size. And then maybe how many hours a day. So we don't want to assume that you're going to walk for 24 hours a day, right? So hours per day, yeah.
I think the font size is still pretty small.
We have to make it big. Sorry, on every screen you have to do this. Maybe the middle one, yeah. Yeah. Okay, and then you do the colon. Okay, enter. And then, yeah, just write pass for now. We'll come back and fill this out. So I'm going to just come top down, okay? So this is, I just want to show you that this is pretty tricky stuff. It's a little abstract to think like this, right? You've got to start from the top and say, what do I need to do? And what information do I need to do this? This is how we write functions. right? Otherwise, we will end up writing a lot of code that is very tedious for us to manage, right? So, okay, so what is the next thing that we want to do is, we might want to convert miles to feet. So I know at some point the width is going to be specified in miles. The size of the step is going to be in feet. So let's def a function. Let's just call it miles to feet. Okay, and it takes 2 parameters. We can call it just distance, right? We can, yeah, just one parameter, just the distance. We can call that parameter distance. And then you put a colon, just distance is enough. Just one parameter, yeah, and then a colon. And then we can say return. Okay, let's do right of this function. It's easy, yeah, return. And distance times, you have to multiply by 5,280. Okay, I know this number from writing the code earlier. 5280. Okay, so if you can write the function quickly, write it. But because we are going after this structure, if the function takes a little more time, just put a pass there. Pass tells Python, I intend to write this function, don't complain. But of course, we cannot use this function, but it allows us to see the structure emerging. Okay, so miles to feet, useful function. It has been written. You can also see how you can easily separately, when you're writing this code, you can just test this function. You can pass in different numbers and make sure it's doing the multiplication and the logic correctly. So now what do we need? Yeah, exactly. For example, and print it out. Perfect. Yes. Right? So you should test as you go along. In the next class, I will show you how we can use test harnesses to do this for us automatically. Okay, but of course you have to write the test, but it can run the test automatically. We can do better than print statements. Okay, so what is the next function we might need, right? So for example, how do we calculate the width of the country, right? So maybe we can create a function there which says, we are going to use this aeroplane model, right? So we can say, this is going to be a speed problem. So let me see. You can tweak the name, but I'll propose a name. Distance traveled. Yeah. So we need speed as one parameter and time as the other parameter. Okay. Colon. And now we'll just return speed times time. So notice as we are writing this code, we are building little blocks. And this block in a real world scenario, you can reuse this block again and again. Every time you want to convert distance to feet. So you'll put this in your own little library and you'll reuse all these functions. Right now, I'm creating all these functions to teach you how to decompose the problem, to see the function there, right? Otherwise, it's just a line of code. But once we see it as a function, we can forget about the logic. And we can just say, give me speed and time, I will compute the distance. I don't care how complicated the calculation is. And then we can start plugging these functions together, okay? And so just, I don't know, you could tell me on chat, are these kind of the functions that you came up with on your own or not? Maybe. So this is a soft thing, right? There's no hard rule, but it's a good guideline to say, structure your thinking like that so that little units of behavior can be pulled out. Sometimes you can actually write the logic and then write the functions afterwards. So that's kind of bottom up. You write a big blob of code and then you discover the functions. Otherwise, it's nice to go top down, right? And say, what will I need to do my work? Okay, keep going. So then what is the next one we need? Somewhere we would have, if I know how many steps are there. So let me call, I don't, okay, let's call, so one of the things you're seeing here is this, like miles to feet, there are a lot of converter functions that are helping us to convert from one unit to another. So the next converter function that I think is useful is one that allows me to convert steps to days. So let's call it def steps underscore to days. Okay, and it will take steps. And to convert steps to days, what is an extra piece of information we need? We need to know how many, because we're going to assume that you're going to take one step every second. So if you give me the total number of steps that you need to take, And I want to figure out how many days will it take for me to make this many steps. So the first parameter is number of steps or steps. And then the second parameter is how many hours I will walk in a day. Okay, hours, yeah, hours in a day, colon. And now here, how will we do it? Return steps divided by hours in a day times, we said that in each hour we'll take 1 step a second. So 3,600 steps in an hour. So yeah, that's it. So you see how these little blocks of code encapsulate some thinking, right? And once you've thought about it once, you can forget about how was it computed. Okay, that's good. So now we can come to the big function, right? Which is time to walk across the country. That's the function we wanted to write. Yeah, you can even copy it from top if you want. It's in that purple color. Yeah, okay. Yeah, walking time. Yeah, actually you have it there. So let's just go up and write it. Sorry, I'm sorry, I didn't. Yeah. So let's get rid of the pass now. Yeah, get rid of the pass and start writing. So what do we need to do here? So first of all, we want to get the number of steps, right? Suppose somebody gave you the width of a country. So let's figure out how many steps we will need. So number of steps. It should be underscored. Number underscore steps. You're doing a wonderful job though, typing. Well done, excellent. Number of steps equals. Okay, so now we can invoke a function. Which function will we use? We will use a function that converts distance to steps, right? So yeah, okay, sorry, yes, miles to feet. Yeah, so the width is coming in miles. So you pass in width here. Yeah, miles to feet needs, yeah, you need to give it width. And now what? We got something in miles, which has been converted to feet. Now we need to convert feet to steps. So do we have something that converts feet to steps? We don't have something that converts feet to steps, right? So we need one more function. So actually we can just do this. Sorry, I'm sorry, we don't need this. So this is a delicate decision, right? So to convert feet to steps, a step is 2.5 feet. So you just divide by 2.5, right?
Sorry to interrupt. Isn't there a parameter step size in there? We can't divide by that?
Yeah, that's what. The step size is that. So yeah, step size, correct. Step size. Slash, yeah, step size. You just divide by step size, basically. Sorry, I said 2.5 because I converted it to the number. You should put step size there. Okay, it's a little hard for me to think about code in words, okay? My fingers do the work usually. Okay, so we got the number of steps, right? So now we can convert this to days. So let's do that, number of days. Okay, equals. So now how do we convert steps to days? You have a function to do that. Yeah, your function, steps to days. Yeah, exactly. You can copy it from there. Steps to, yeah. Okay, and yeah, number of steps. And what's the second parameter? Hours per day. Just no, you just pass it in. You see the parameter on top, it says hours per day. You have to put just hours per day. Yeah. Okay, let me just pause for a second. You can see that this is a kind of plumbing thinking, right? How to move information through our functions and let the functions do the work. We have not hard-coded any values. So later when we supply the values, it will always do the right thing. So we've got the number of days. For now, let's just not even return it. Just print it from right there. Just print number of days right there. No, sorry, inside the function though, at the same, exactly. So this function will compute the number of days and display it as well. Okay. So it's all looking good. I think we're ready to assemble, but now we need one more function, which is, okay, I think we're good. Now we need to get inputs from the user. So how do we get inputs? So what are the inputs we need? We need, let's come outside this function, all the way at the bottom, maybe on line 16. Okay, even there you can do. So what are we going to ask the user to give us? Travel time, maybe travel time by flight equals, and now you have to use the input function. Input bracket, and what's the message? Please enter travel time, something like this. Later you can tweak all these, yeah, enter. Travel time, colon, space, just to make it pretty. Colon, travel time, colon, space. Yeah. So this will come back, but immediately now I'm going to prevent a bug from happening. This will come back as a string. What do we want to do? What do we want to do? What do we want to save it? No, you should put the float after the input, on the left of the input. Yeah. Okay, so again, we must think about what is coming back. Good. And then go to the next line. Okay, so now next one we need is maybe the speed of the plane. We're going to just ask speed of flight or speed of plane, or yeah, equals. And you can put the float already. We know it's a float coming back. Input. And then you can give some message. Please enter speed of flight or speed of plane. Okay, I want to tell you one thing here. You can see this program, even though it's a little tedious, it illustrates a lot of important programming ideas. For example, I'm communicating with the user. What's a friendly message to give to a user so he will not make mistakes? So for example, in the travel time, maybe you want to enter travel time in hours. So yeah, put a bracket or something and say in hours, right? These little things are causes of many bugs in industrial strength software, right? When we write bigger programs, you make an assumption. Yeah, exactly. So all this, but now you see, it's a pain to think about it and then to type it. So if you get lazy and we cut corners, it causes problems, right? So it's easy. You can see sometimes when you're frustrated, I'm sure all of us have been frustrated with software in the real world, but the reason is here. It's hard to think about this and then be patient and be explicit about everything. Okay. And all of this can be built by you guys just by practice. Okay. Writing some programs, feeling this, oh my God, it's so hard to write a message to the user. What am I going to write? And then develop the skill to generate those messages very quickly, right? The skill to convert. Right now, we are automatically converting everything to float right away, etc. All these become part of your programming thinking process. Okay. Okay. So the next one is step size. We need step size. So again, same one more message. Yeah. Yeah. And then a friendly message. Enter your step size in feet, maybe. Now, while you're typing this, I want to say, usually in my programs, I take all, we are not going to do this today because there's one idea I need to give you. I take all of these inputs and make a function called interact with the user and get inputs or something. And then it's all sitting inside one function. The only problem is that function needs to return multiple values to me. And today our functions are only returning one value. So I'm not going to put this in a function, okay? But you can see there's a lot of user interaction even for this small program. Okay, what else do we need? How many hours will you walk in a day? Yeah. Hours per day, yeah. Okay, just a second's pause quickly. Can people type in chat and tell me, how does it feel writing a program like this? Is it easy? Is it what you would have done? I have one person, my favorite volunteer here typing away furiously. But is this the way you're thinking about, you would think about this problem in terms of functions? Can you share me something in chat? No? Context switch? This is easy, this is hard, at least? How many of you think it's easy? I should have put a poll here. No, I'm not seeing anything in chat. Okay, we'll continue. We'll continue. Okay, yeah. Okay, so hours per day. Okay, so we got all the inputs. Now it's time to do the computation, right? So first thing we need to do is we need to compute the width of the country. So let's calculate the width of the country just after the inputs on line 20 maybe. Just create a new line. Yeah. Width of country. Yeah, equals. Yeah, float. No, actually now we're going to compute. So no more float, no more. We're going to compute. So we have the information. How do we compute from this information? How do we compute the width of the country? We have travel time. Yeah, no, there's a function to do this now. Distance travel. Distance underscore travel. Yeah, bracket. And now pass in travel time. Sorry, speed and then travel time. Sorry, first one is speed. So speed of plane, comma, travel time. Okay, so this will compute the width of the country. Now we need to compute time to walk across the country. So you can either compute it, if we run this function, it will actually print it out for us. So let's just invoke that function, enter, and the big function, walking time. Okay, put bracket and just pass in all the parameters. Width of country, comma, step size, comma, what's the next parameter? Yeah, hours per day. And that should be it. Okay, take a deep breath and run it. I don't think we're going to debug this, but okay, you can enter. Yeah, travel time. Yeah, you should enter something now. Yeah, speed. Okay, it looks like a real program, right? It's asking you for information and then it's going to do something. So it's a wonderful thing. There's a nice little bug in this code. Okay, but I want to not take up the whole session debugging this. Okay, I can see it, but I don't want to solve it. But I just want you to understand this is how you process, right? You take the problem, you break it up into steps. So here's what I can promise we can go through this line by line again in office hours and make sure that it's actually working correctly. Okay, so is it okay? I'm going to just move on. I really was doing this exercise to say that thinking like this, I'm trying to show you how an abstract idea, right? How to take a big problem or a small problem. This problem was interesting enough because it needed 5 or 6 functions. So it's hard for you to get this experience otherwise, right? You need to take a problem with some structure and then figure out what are the ingredients that can help us solve this problem. Okay. And I didn't want to sit and debug this, but we are almost there, right? And it's hard for me to debug over the screen like this. So we just need to be calm and check it out carefully. Okay. Okay. So now one more idea, function composition, right? And so this idea is that if you have 2 functions, you can pass the output of one function into the other function. This is a very important idea, right? So for example, here, if you see, there are 2 functions and I can take if I pass in the value 3 to the function double, it doubles it, you get 6. And if you square it, you get 36, right? So it prints out 36. Okay. So the idea here, why I showed you function composition at this point is to say, we can build little functions, then compose them together and we can get complicated behavior. And I think that there's one more section here. I want to, if you go to the next tab, you just go to the next tab. Yeah, next one. This is called recursion. Okay. And what I'm going to do is I'm going to defer this because we have a lot of ideas to cover today. So I'm going to defer recursion It is a very interesting topic. If you're interested, we can either cover it later in today if there's time, and or we can discuss it in office hours. Okay, but I put some material for you to play around with, but we'll come back to it as the opportunity provides. Okay, it's a slightly more advanced idea with functions. You can tell me in chat if you guys have used recursion before and how easy you found it. Okay, but for now, it's not necessarily the most important ingredient that you need. Okay, so then let's go to the next section. Again, is everyone with me? Hard, difficult, easy? Okay, everyone's kind of with me. Okay, keep me posted in chat. Okay, I'm looking as much as I can into chat. Okay, so now let's go to the next most important topic here, which is this idea of the mathematics of logic. Okay, this is one of my recently favorite subjects because I was reading about George Boole, and I wanted to share this beautiful story that George Boole was a mathematician in a very small university. He was at the University of Cork. And when he's a peer of great mathematicians like Newton and Leibniz and so on. And what was happening is that Boole was coming up with this idea that he wanted to study how to think about the structure of thought. And everybody was interested in the property of numbers and real numbers, doing analysis and calculus and trigonometry, all these algebra. These were the subjects that people were studying. But Boole went away and said, if I want to study thought, what do I need to build up a mathematics of thought? And this is a beautiful moment when he realized that there's a lot that I can do in the mathematics of thought if I create a new type of variable, which has only two states. Like a number can take infinite number of states, right? But a variable that has only two states, think of it as true and false. And Boole then proceeds to write this book called The Laws of Thought. And he lays out this whole architecture, right? It says, and the architecture is very interesting. It was not by following the crowd of mathematicians who were all studying, real numbers and doing all these complicated things with calculus and so on, but by going away, finding an interesting problem, and then having a very simple idea, right? I have to change the set of variables I work on. And he created this beautiful idea that if I have true and false, I can build up logical operations on top of this, and we can get started. So again, it's a very big idea. I cannot do justice to it in a couple of minutes, but I want you all to think about this, right? That in mathematics, most of the time, we think about either discrete integers and or real numbers. And now we have a new world. And it's interesting that this world is the world of computers and thought and logic and all that stuff. Okay, so we'll explore this a little bit. So the first idea is to recognize that there are two values. And in Python, they are the Boolean variables, right? We've seen Booleans before. So let's just go to the next section. Okay. So the next question we have to do is, once you have a Boolean variable, as we do with any type, the next question we can ask is, how do we operate on these Boolean variables? Okay. So as soon as you create a type, the first thing we can ask is, what operations make sense on this type? Okay. And Boole discovered this right away. So I'm showing you the thinking pattern that you use. If you create a new type, I'll show you later how we create our own types. But if you create a new type, you immediately ask the question, what operations make sense on this type, right? And so it leads us to a certain conclusion. And what Boole came up with this idea is that if I have two values that have, say, if I have true, one value which is true and one value which is false, I could combine them. And today we almost understand it, but as a logical thing, the combination is called an AND. So AND takes two values and combines them. Okay, what are the rules for combining these values? So now another big idea, in mathematics we learned that if you have a function, there's also a table that you can create. For example, we use this in mathematics to create graphs. If you have a function, you give x values and you compute the y values, you make a table. You take 5x values and you compute 5 y values, right? But tables are thought to be small portions of a function because there's an infinite set of values you can give. But in Boolean variables, there are only two values you can give. So there are only four. If there are two inputs to a function, there are only 4 values that are possible. So the entire function is summarized by this table. Right? So it's very cool. These tables are called truth tables. And the idea is that rather than telling you the definition of what is AND mean, I just give you this table. And if you want to know how AND operates, just take the values of A and B and you read the third column, right? And then you're good, right? So it's a very easy protocol for you to follow to think about functions as tables, okay? So now this is the truth table for the AND operation. And basically it tells us that for this operation to return true, both values have to be true, right? A and B is true only if A is true and B is true. And so even logically, it makes sense, A and B being both of them true. So I'm going to pause here and just absorb this idea. So now quickly, a little piece of code. We can just pass in two values and so let me just say in Python to compute 1 second, let me just increase the font. To compute this operation, you just take a variable A and then you use the word AND, right? So the logical operation AND is represented by the keyword AND, right? So A and B will evaluate A and B, right? So what I've done here is to say, okay, if I have 4 possible values, I just wrote a small function here. You guys can play with this. The core of the function is evaluating A and B and then just printing it out. So if I run this code now, I can see the whole truth table, right? But for now, you should just be able to create the core part of the truth table, at least like this. So immediately, yeah. Okay, so there's another one here, just quickly, just this line I want you to focus on. When you have multiple operators, so there are 3 operators that I want to talk about today. One is not, but not is actually easy. It's just if the value is true, no, if A is true, not A is false. Okay, if A is false, not A is true. It just flips the Boolean state. And we have already seen, and now OR, okay? So I'm not going to ask for a volunteer because it's a small exercise, but can you take a second and print out the truth table of the OR operator? Okay, I'm just going to give you all a quiet moment of reflection and typing code. I should hear a thunderous sound of so many keystrokes. Is everybody going to type something? If you're not even writing the whole thing, at least say A equals true, B equals false, and then you can type A or B, right? So that will evaluate it. And if you want to see it, you can just call print on it. Okay, and then you can just try all the different values. Okay. Now in the previous code section, I had made a comment to you that clearly you can see this code is very repetitive, isn't it? It's doing the same thing again and again. And I put a comment in there that says, when you find yourself repeating an action multiple times as a programmer, you must say something is not good. How can I do this without having to type the same code again and again? And we have elevated that to a principle. It's called the DRY principle. Do not repeat yourself principle, right? Because it's very natural in programming sometimes to just simply, like I did here, just repeat the action 4 times, just copy paste it and change the value, right? But if you ask the question, how can I automate this? It leads us down a very interesting path. You are not going to be able to write this code right now, but I just wanted to show you that I can write that whole thing in one line. This is just to show off some Jedi stuff, right? So I will just turn off the other one and just say, we can actually write that whole 4, instead of copy pasting 4 times, I can write 1 line and it will generate the same output, right? But I only show this here not to show you how to write it. I will show you how to write this particular code later. But I show it here only to say, whenever we see repetition, a red flag should go off, right? And say, I want to find a way that I don't repeat, copy paste the code and change values. And as you get to be a better and better programmer, you will completely minimize repetition, okay? Now, as I'm working with you and we're writing code, I want to share with you this idea. It's nice. It's a very challenging thing to talk about your code and write it at the same time. But it's really useful because it forces me to explain something to you and you can ask questions back to me. So it's an interactive style of programming. Okay. So it's very useful to do it. Okay. So that's the DRY principle. Let's continue with our exploration of logical operators. So we understood the AND and the OR, and now a moment of writing code. Who would like to write this code? Can I get a volunteer? All right. So Parker, you're ready to go. I would just say to you that if you can just maybe, for me it's fine, but if you can click that hamburger menu and make the font bigger. Yeah, there you go. Okay, I love it that you guys are offering to write code. It's something I want to do more and more of, right? That you guys will write it. You'll also learn it better for sure. Okay, so let's get started. So we want to basically get some inputs, right? So can we get two inputs? So we have to first give some variable. Let's call it is sunny, for example, maybe. Is sunny? I don't know. If sunny, good. And then you get, say, input. Yeah. Just to save yourself some typing time, I've put some input up there. You can just copy it from there if you want. Yeah. Right? So basically it says, yeah. And okay, it's nice that there's a bracket there. See, there's a bracket. It's the start of the line. So let's use that bracket. Do we want to convert this to something? It's coming back as a string. What would we convert it to? To a Boolean, right? So can we put the keyword bool there? Yeah, bool. Okay, so always get into the habit, we get into the habit of making everything into the type that we want. Okay, so we got these two values. Now your job is to print out something, right? So what is it? So is Mary happy? So how do we compute? There's a line on the first line. She says it's happy only when it's sunny and cold. So what is that condition? It has to be sunny and not cold.
So let's say so. If let's see so.
Yeah, if. Yeah, okay, Mary happy, correct. You don't need an, yeah. If sunny. Yeah, yeah.
If sunny, fire.
And yeah, and it should not be cold. If cold. Okay.
Yeah.
Okay, so let's just create a print statement quickly. Print Mary happy. Okay, later you can write a full sentence there. Okay, but let's check our logic again quickly, right? If sunny and cold, are you happy when it's cold or you're happy when it's not cold? You can't put it inside the variable, right?
Yeah.
There's no variable. You have to put the not before the variable. So make it if cold, and put the not before the variable. Yeah, and not. Okay, and yeah, you put the brackets, which is nice thing to do, but I want to tell you that not has a higher precedence than and. So you don't really need the bracket. Leave it alone for now, but I'm just saying understanding operator precedence will allow us to eliminate some extra brackets. Okay, so let's run it and see what happens. Yeah, you have to click in the right side and hit enter. Sorry, yeah, after you hit put T, what happens? Something is come. Oh yeah, yeah. Oh, there's a T. Yeah. Oh, by the way, this is something for all of you to know. If you're running code, when you're entering input, you must click in that input right side panel. Otherwise, it enters stuff into the main place. Yeah, you got the answer, right? Is it good? No.
Yeah. Doesn't appear to be. Yeah. Don't know
Okay,
what's
so
up.
let's just debug this. Yeah. So what's going on? So can we just print out those variables quickly? So this is nice. So I just want to show you guys, when things go wrong, it's natural to panic, but can we put some couple of print statements? Just make sure everything's working correctly. No, you can put it up just before or after Mary is happy. Just print if Sunny.
Print if Sunny.
On line 6. Just say print if Sunny, so we can see what has happened. Okay. Can everybody see the bug in this code? It's a tricky bug actually. But when we do these print statements, you will see this. Okay, stop. Just hit you. Yeah, stop and run it. Okay. T. What happened? If Sunny is true and if cold is false is also true, even though you entered F. Okay, so now I'm going to explain. This is why debugging also for me is hard, because I don't know what is the bug we just created, but it's actually a very subtle bug. The subtle bug is that we entered T, but Python doesn't know that T stands for true, right? So if you wanted T to become true as a Boolean variable, you have to convert the T to the variable true. So before we fix it, let's run it again, but instead of entering T, let's enter true and see what happens.
So Vijay?
Yeah?
In Python, any string is actually a true value if treated as Boolean.
Yes.
So currently false is taken as a string false.
Correct.
So you will have to compare it against string false or string true to make it a Boolean value.
Correct. So okay. So
comparison.
That's
double. Yeah. So
yeah, that's exactly correct. Okay. So yeah, so this is where the debugging comes in. So what is happening here is exactly what Amey was talking about. I now remember when I was writing this code. So this is a beautiful example of what we talked about earlier. It's type conversion hell, right? So exactly what is happening is the input is returning a string, right? And if you ask bool to convert a string to a bool, as long as the string is not null, it will always return true. Whether the string is true or false, as long as the string is not empty, it will always return true. So right now this bool conversion is not working correctly. And it's a subtle bug, but of course, it's a bug that we have to catch and handle. So what do? So we solve this by writing a function. So let's write a function, def convert space convert string to bool underscore string underscore convert string to bool, right? And you put a bracket here and we pass in a string. You can give it some name, a string, a underscore string. Yeah. Okay, close the bracket, colon. And then here, enter. Yeah, enter. And we're going to come to this later. That's why I took this out, but obviously I need it. If, so let's just write an if statement here, okay? We'll come back to an if statement later. So if space a string, we'll come to this in a minute, okay? A string equals true, equals double equals for equals, space, and now it's the actual string. It's, you have to put a string around it. So we have to compare this value. No, just a quote around it, single quote. Okay, double quote is fine too. Single quote better, true, colon, enter, return. Now we make it into a Boolean. So return capital TRUE. Capital T, RUE is lowercase. So what we have done here is we have converted the string true into the Boolean variable true, right? And then you put an enter, else. Yeah, the else has to be in the same line as if. We will do this if statements in a minute. Just put the else outwards. Yeah, and colon, enter, return false. Okay. So now what we have to do is, instead of writing this bool here in line 8 where we have bool, you have to put this convert string to bool. Right? Copy that whole, no, you have to copy convert string to bool, that name of the function. Yeah, you don't need the parameters, just the name of the function. Yeah. And just replace the bool with convert string to bool. Where bool is written on line 8. You see bool on line 8? Yeah. So the idea was that the system built bool was not clever enough to convert the string. So we have to actually convert the string into a Boolean, and now it should be happy. Yeah. Okay, so now it works. Mary is happy. Yeah. Okay, so you can see subtle bug, right? And of course it needed this if statement. So this is why in my thinking, I was thinking I could just use the bool converter in the system. Let's come back to this once we do if statements, but so maybe it was a real live demonstration of how type bugs, which I've been talking about since last class, right? That when the type is not set correctly, there is a problem. And here the assumption that the string true will get converted into the Boolean variable true by the system built bool converter is not correct. The bool will just take any non-empty string and make it true. So we had to write our own type converter. Very subtle bug, very slightly advanced. If you don't get it in the first pass, it's okay. Okay, we can go to the next section.
I think Amay has some comment.
Yes, Amay.
Yes, so I was saying empty string gets converted to Boolean false value.
Yes.
So if you just press enter in the previous
of course
program, then it will take it as false, and any other string, whether you type T or true or F or even a space, it will be taken as a true value.
Correct. So I think Amay is just reiterating what I'm saying, right? That simple bool that we used will not work if you don't write this type converter. Okay, anything other than an empty string will always convert to true, which we fixed by writing our own type converter function. Okay, which is a heavy way of doing it. Okay, so now let's continue on this path. If you don't mind staying with me on screen so I don't switch back to myself, you can write one more small program. Maybe this one will be easier than the other one. So next idea, important idea. So we're slowly building up our logic, right? So the first idea was that we can have and Boolean variables, then we have and, or, and not. We can combine them. Now we have this idea of comparing things, right? So if you take two values and you ask, is one value greater than or less than the other? Then you can compare different values. Can you just go back to the signature of the comparison operator quickly? Yeah, so here, just I want you to have this idea, right? Although the comparison operator is not written as a function, if you think about it as a function, it takes two values, A and B. Values can be any type. They can be integers, they can be floats, anything. But when you make a comparison, it will always return a bool. That's why it's in this section, right? And we build our logic by using comparison operators. So you can ask whether two values are equal. Notice the double equals here. Remember last time I told you the single equals is an assignment statement. The double equals actually checks for equality, right? And then the other operators, you can take some time to get familiar with them, but it's greater than, less than, greater than, equal to, and not equals, and so on, right? So these are all the comparison operators. And I guess the only way to learn this is to write a small program. So let's go to the next page and write a small program. Okay. Hopefully this one should be easier to write. Okay. So what do we want? We have some logic. Actually, this is a nice little template for thinking about how a temperature controller would work. So if you go to main, I'll help you write it. So if you go to main, by the way, in all these things, I have provided solutions for you. Okay. So you can also look at those solutions. But okay, so we have to write this function. And the idea is, imagine that there's a temperature controller, a thermostat. We are writing some code for this thermostat. And we are allowing the user to define if some logic that we can, this function will create some logic that decides if a temperature is in your comfort zone. But here we're going to hard code that logic. So we delete that pass and just read what is the idea. So we want to take a temperature and we want to return a Boolean if the temperature is comfortable to me. So usually how do we define our comfort zone? It has to be, so what would be your comfort zone? Temperature. Yeah, 60, is that a good number? Okay, we can use, right? 60 to 80. So the temperature has to be greater than 60 and less than 80 degrees. So you're going to return a value. Yeah, and now we're going to check if the temperature, so we have two checks if you want to write it this way. Can you check what are the checks you want? The temperature is greater than 60. No, before the return you must write it. Yeah, space. We can write it in one line. So yeah, temperature greater than 60. And then what? And that's it, right? And notice here you must ask questions like, do you want greater than equals or strictly greater than or strictly less than and so on, okay? That's up to you, right? It's part of the logic. In some cases, if you don't have the equal to, you'll get a bug because 60 will not be considered. Okay, and then you can run this program basically, right? It gets an input, oops. Line 3. Okay, first, so let me simplify it. Just take off the less greater than equals. Yeah. Okay. Let's test it out now. Does it work? Test another number. Okay. So now when you put so the problem was with the equals. So the greater than equals is the equal to is always on the right hand side. So temperature greater than 60, the equal to is always on the right hand side of that symbol. Greater than equals or less than equals. The equal to is on the right hand side of the other one too. Yeah. Now try it again. Yeah. Enter the temperature. Yeah. Okay. It's a little hard for me to debug when you are typing, but okay. And it's hard to notice those little bugs like where the equal to goes on the left hand side or right hand side. That's where we do practice so that we don't make the bug. Then it's hard to detect a bug quickly by reading it because my eye is always used to having a well-defined less than equals operator, right? So it's hard for me to think the operator is not working. But this is part of a very difficult skill set. So writing this code and having bugs and fixing them is a skill set that I want all of you to develop, okay? Our programs will break, right? No matter how skillful we are, small mistakes will crop up. So the ability to be calm, reason about it, keep trying until we can isolate the problem and eventually fix it is a huge skill to develop. It's not something I can just tell you and do it, right? It's just one of those things. It's like running a mile. Just only way to do it is by running the mile. So I want all of you to just start writing these programs, hitting some of these problems, coming up with your own strategies to solve this problem, etc. Okay.
There's one question from Ahmed
Yes.
on the chat. So
Yes.
if you can
Sorry.
answer that question.
Yeah, sure. Let me see.
It's for the participants.
Okay. Can we write?
Yes. So in mathematics, we typically write, right? X less than equal to Y less than equal to Z.
Yes.
To say that Y is between X and Z.
Yes.
Z. So can we write similarly in Python? So people should try and figure out if there is an issue.
Oh yeah. Actually, yeah. Maybe what Amaya said, you can just do it. In fact, that's the way I do it usually. But it makes a compound class, right? You can have basically So if we can just type it below, do you mind just typing, put a comment and just type it below in this window? Yeah, put a hash. Yeah, put a hash, space. And so you can start with the lower condition, 60, less than, say less than or less than equal, just do less than for now. 60 less than temperature. 60 has to be less than temperature, right? And then temperature is less than 80, right? No need even and, just write it as one long thing. Yeah. So this represents an interval. As Amay was saying, in programming, in mathematics, people would write something in an interval like this, in one compound structure. The answer is Python will accept this too. But why don't you take that as a small thing to explore? Okay, Python will accept this. So you can replace.
That is the question, will it accept or not?
Yes, that's for you to play and try. The answer is yes, right, Amay?
No, it will be no.
It will be no.
In this case, it is no. Yes. That's why I want people to try it.
Okay.
Let's see what happens.
Yeah.
And give something. So give 3 different values, less than 60, greater. Sorry, not here.
Try 90. Yeah. Less than 60. So 45. 90. Yeah.
Okay, so it is working. Wow.
Yeah. No, I actually tested it, Amay. I actually wrote the code this way, but I did not. Okay, this is a beautiful discussion, right? So the whole idea here is it's exploratory programming. You must write and test it out, right? So I actually wrote the code this way first, but then I thought it's a compound class and it's a little bit more tricky. And anyway, I want to show you how to use the AND operator. So that's why I made it 2 classes and joined them with an AND. Okay. So, but welcome to the world of programming, right? It's an ongoing journey. All of us, there's details, different languages do different things. So we must keep trying, okay? And I think the point there is also, there's something you can learn from a book, but it's more important like we did just now. Amay asked the question, does this work? We understood what he was saying, we wrote it down, then we tested it and we know now for sure it works or it does not work. It's a wonderful way of learning. Only programming supports this exploratory style, right? It allows us to really, computer will check it for us and tell us whether we're doing the right thing or not. Okay, so any comment on that, Amay?
Something that I learned today. So even I am not that that comfortable with Python.
So these are all cool things, right? And again, I want all of us to be in this mind. It's not that I am supposed to have all the answers or anyone is supposed to have all the answers or Amay has to have all the answers. We're all exploring these languages and getting sharper and cooler at doing it, right? So yeah, I think we should all be comfortable with being wrong sometimes, even myself, right? So it's hard, right? It was like, oh, I should know. No, it's okay, right? Once we learn it, but maybe tomorrow we will be sure about it. Okay, so now I want to just take 1 second and pass through this. If you can go to the next screen, please. Yeah, perfect. And just make the font a little bit bigger. So I cannot pass over this wonderful opportunity to show you a very interesting problem in computer science. And the problem is, beautiful thing about computer science and number theory, 2 of my favorite subjects, is it's easy to set up very simple problems that are actually research problems. So here's a simple problem. There are 3 Boolean variables. A is true, B is true, and C is true. And there is a constraint. The constraint is a logical clause. It says A and B. It's a complicated thing, but it's just a combination of these 3 variables with some ands and nots and ors and so on. It's a Boolean constraint. And if you just run this code, it comes out to be false, right? It doesn't, the constraint is not satisfied. So the question is, can you find an assignment? So you change A to false or B to false or C to false. By changing A to false or true, can you find an assignment of the 3 variables that makes this constraint become true? Yeah. So we are trying the brute force method, right? Change 1 by 1, right? And see what happens. So how many combinations are there? You're going to find it in the next try. So don't give up hope. Yes. So we solved it, right? So this is the assignment that satisfies this constraint. So first question to all of you, how many, can you go down? There's a quick poll maybe below. Can you all take it? How many, if I have n such variables, how many different combinations are there? If I have to check all of them, right? I'm going to change each one of them. I'm going to set true, false, and check all possible combinations. How many different combinations are there? Is it n? Is it 2n? Is it n squared? Is it 2 to the power of n? Okay. Okay. So we have all kinds of different answers. It's okay. Let's look at the answers quickly. Let's just see what people came up with. So you can see there are different answers, right? But now let's calculate it. So each variable can take 2 values. So if there are 2 variables, it's 2 times 2, 4 possibilities. If there are 3 variables, it's 2 times 2 times 2. So there are 8 possibilities. Please take a minute and just evaluate this on paper. Okay, it's all right. First time you do it, counting like this. In fact, I struggled with it as a student a lot. I didn't like counting problems. But the solution to that is to just type it out and see. Write it out on a piece of paper. So basically 2 to the power of n configurations are possible. And so this problem, finding an assignment of A, B, and C to satisfy a constraint. Suppose I had a constraint with 50 variables in it. It will take 2 to the power of 50 tries for me to possibly find an answer. For 100 variables, it will take 2 to the power 100. It's a homework assignment for you to figure out if I have 100 variables and I solve a constraint like this, how much computing time will it take? And if you actually calculate this out, you'll see it is very, very large. Large like the life of the universe and so on. You'll get very large numbers when you do this type of thing. Okay? So this is an example of a problem. It's called the Boolean satisfiability problem. And in computer science, we take problems and we put them in different categories. And this idea of putting problems in different categories and degree of difficulty is called complexity theory. It's an extremely beautiful subject, and it is the subject that studies the computability, the degree of difficulty of computability of problems. Okay, and it's very beautiful that this simple problem with just satisfying a constraint and a few Boolean variables is considered to be one of the hardest problems we know. By hardest, I mean it's considered to be a very difficult problem to solve because the only algorithm we have is to try all possible configurations. Okay. Now, this problem also has a nice feature to it that if somebody found the answer and gave you the answer, checking if the answer is true or false, if the answer works or not, is very easy. Python can do it in a second to check one value, just one assignment. So, given the answer, it's easy to check that we have the right answer, but finding the answer is very hard. Those kind of problems fall into a complexity class. They have a name. They're called NP hard problems. Okay, and the problems that we can solve easily, usually we have an algorithm that goes like n or 2n, something like this. It's a polynomial in n. Those are called polynomial time algorithms. And you can read there's $1 million question asking whether NP problems are the same as P problems. And that's $1 million question for computer science. But it also gives me a chance to highlight to you why computer science is different than just programming. Right? Programming is about writing programs, making a web page, doing some data science, whatever. But computer science is one major portion of computer science is asking these kind of abstract questions about how difficult a computational problem is. So for those who want to understand the nature of computation, what makes a problem difficult, what makes a problem easy, are there different types of problems? All these questions are a big branch of computer science. Gives me 2 minutes to talk about it. It's a subject I like very much. You can read more. I put some links in there. Okay, so we have covered this topic too. Now we can go to the last chunk of this class, which is actually there are 2 pieces here. Let's see how far we get. We are getting time, right? We're almost time. Okay, so let's do it this way. I wanted to talk about branching and loops, but by the time we went through this, we've used up time. Do we have 5 more minutes? Can I introduce you to an if statement? We wrote one already. So why don't I just quickly do that? Don't feel rushed. There is an office hours on Monday. And of course, in the next session, I will pick up here and continue. Okay. So let me just introduce you to the last two elements. One element here is the if statement. So this is the last piece of logic that we really need, which is to do if-then reasoning. So we have figured out how to combine Boolean conditions. We have figured out how to compare things. Now we have to do if-then reasoning. So if you take so here's the structure of what is called an if clause, right? So there's an ifs. So I'm giving you the syntax of Python as well. You write if, and then you put any condition. Then if that condition is true, all the code that is in between the if and the else, that all has to be indented. Okay? Notice again, I will show you the Python syntax says you have to write an if, you write the condition, then you put a colon, just like you do for functions. So when you start any structure, instead of putting a bracket, you put a colon. The body of that structure could be multiple lines, just like a function has to be indented, right? And then you do the else statement, put a colon, and the body of the function has to be indented. Now, there is a reason why this is called branching, is because when the if condition is evaluated, there are two possible scenarios. And if the condition is true, then everything that is in the body of the if statement will get evaluated. If the condition is false, everything in the body of the else statement will get evaluated. Okay, so that's why the world splits into two pieces, a left branch and a right branch, or a true branch and a false branch, or an if branch and an else branch. And that's how the code gets processed, right? Now, this is a workhorse of all the logic that we write in our programs, right? It's a simple little thing. It's a small piece of syntax, but a lot of our logic gets built into if statements. So just to solidify this, we can quickly look at that simulation that I have at the bottom. Can you scroll down to the bottom? All the way to the bottom? Yeah. So, okay, just one more thing. If you have the need to have multiple branches, then you can add as many branches as you want, but you add this structure called an elif. If you just look above the simulation, you can see if, elif, note it's not else if, it's elif, and then else. So you can have as many elif branches as you want. So if you have multiple conditions, in each condition you want to perform a different action, then you use this multi-way branching structure. That's the most general branching structure we can have, right? An if, then multiple elif structures, and then an else. The else will be the fall through. If none of the elifs are matched, then it will go to the else. Also, when you have a sequence of conditions, if, we can look through it here. So look at this example in the simulation. The variable x is 5, right? And we want to check if x is less than the limit, right? Which is 4 in this case. Actually, I didn't use the limit variable. I just put 4 there. So you can just go forward. So it comes to the if statement. It says, is x less than 4? It's not less than 4. So it jumps to the next elif condition. Is x equal to 4? No, it's not equal to 4. So if you hit forward, it jumps. And then it goes to the else statement. And then it prints out x is greater than 4. Okay, so I want you to build up this mental model of a multi-way branching statement. And then you can start writing code. Okay, so now that we are at time, I don't want to do more here. I will next session, I will start with if statements, and we will do loops and then continue from there. But I would pause for a minute, and if we can just get some questions, you can turn on your microphones and give me some. Was everyone able to absorb all the material we discussed? Was it easy? Yes, no, maybe. I don't expect everyone to say it was easy, right? I mean, clearly there's a lot of ideas here. Do you feel that with a little practice, you will be able to write all this stuff, use all this stuff? Okay, at least one person says good for now. Okay, yeah. So if you feel overwhelmed at this moment, if you feel like, oh my God, there's a lot of stuff, how am I going to absorb all this? It's okay. It's natural. That is to be expected when you see new ideas. But I can kind of promise you that with a few hours of work, and there's plenty of examples right now, and a little bit of quizzes that we can do later, then you will get solidified. These ideas will get solidified. And then the rest of the course, we will use these ideas, right? We'll use functions, we'll use the Boolean logic. And the Boolean logic is a little tricky, right? Because we don't use it all the time. But commit yourself a couple of hours this week, even in this weekend, so while it is still fresh in your mind, just write a few pieces of code, right? And either send me email or post on the forums, and on Monday we'll do the office hours. Please ask your questions. Okay, don't just get overwhelmed and say, oh my God, it's hard. How am I going to do this? Okay, please raise your questions. Talking about it will help. If you don't want to talk too much, I'm happy to do the talking, but you have to ask the question at least. Any other questions? Otherwise, I will let you go. But yeah, just to confirm, class will start. Okay, so yeah, somebody asked a question about the quiz. That's correct. So the quiz is intended to give you time to practice and chance to practice. Do as much as the quiz that does not involve the if statements, okay? I will extend the quiz until next Friday, right? So until the Friday after next, because I won't cover this until next Friday, right? So the quiz right now is set to be completed by next Friday. I will put it back by 1 week. So you have time to observe, but please don't use that as a reason not to start doing the quizzes and practice, okay? Not practicing for a week you will forget all this stuff. So please stick with your 3 hours a week practice schedule, okay? Sit down, write some code, get at least up until the if statement, play with the Boolean variables, etc. Right? And delete all the code that's there and write your own versions of everything. That practice will make you feel very good after you've done it. The problems are simple enough, so you should be able to get them to work. Any other questions? So everybody doesn't want to turn on their microphones, or do I have to do it for you? You can just unmute your microphones, right? Some people have technical problems with microphones, I think. But any other questions? Okay, then I'll let you go. We have used up the time. Thank you so much for your attention. Please don't feel overwhelmed. Put some time to do practice, okay? And after the class, if you have any questions, send me email. I will write immediately or within the day, okay? So if anything is troubling you, just don't hesitate. Have a great weekend and make sure you get a couple of hours of practice. Thank you.